For the first, the deadlock management. So that the chapter 7 is, even though that is a part of the process management, we didn't cover in the midterm exam. So chapter 7, we are going to start from the chapter 7, then to the chapter 13 for your final exam. In the chapter 7, we talk about the deadlock management. So you need to understand what is a deadlock and what is the definition. There are requirements of the deadlock, so and the solution of the deadlock. Okay, so it's not clear sometimes what is the prevention, what is the avoidance, and what is the detection. Okay, you need to clarify. Then using the Banker's algorithm. Banker's algorithm is nothing special, so you can check the in and out. So if you can manage the in and out, that will be done. There's no problem. It's a safe state. Otherwise, if you stop, then that will be the non-safe state. Non-safe state is not always the problem, but maybe problem. So we will consider that is then maybe the deadlock. So we can do something. We can revoke, decline, or something other. So that is the deadlock management. But nowadays the most popular solution of the deadlock is ignored by the operating system because it's expensive. But as you have seen in the database class, database should take care of such a deadlock situation. So deadlock is always like the synchronization problem. It's in any computer system, deadlock is the problem because we share the same resource by the multiple producer and consumer problem. So we have the multiple transaction, multiple processes, so we need to take care of that. In the chapter 8 and 9, we talk about the memory management. Memory management is the relatively small portion of the others, but it's more important in terms of the performance. So in the memory management, so we talk about how to allocate the memory, and so it's a contiguous allocation, but the contiguous allocation problem of what? The fragmentation, as you can expect. To address the fragmentation, external fragmentation, we can have the segmentation approach. Segmentation is a group of the chunk of the memory still equals the problem. However, the contiguous approach, we can use the best fit, worst fit, or the first fit to allocate. But that has been used a long time ago, not practically used the current operating system. Current operating system instead use the fixed size, small fixed size of the unit that is called the pages. Okay, then page will be used, as we discussed today, will be used what? Virtual memory. So anyway, we do not have enough space in the physical memory. We will consider such a logical memory, which means it's a program as the memory. So it's allocated. We pretend they are allocated to the memory, but doesn't fit to the physical memory. Instead, we will load on demand. So whenever need, we can page by page load. If we cannot find the page on the physical memory, then page frame, which means so we can see the virtual space. So such a virtual space is named as sometimes swap in case of the Linux. But that swap idea is the same. So swap in and out. Similarly, we can do the page in and out. So number of page in and out is the very important indicator to judge your performance of your system. So mostly in case of page fault is what? It's the trap, it's an event, something unusual, something wrong. So we need to replace the pages. Today we have seen how to find the victim pages. Okay, so that is the memory management. Then the rest of time we talk about the I/O management. So CPU, memory, I/O. So actually, CPU and memory also I/O device. We can consider all the devices connected to the computer system as I/O devices. CPU is also I/O device and the memory, but they are specialized components. So separate, then the other we consider the I/O device. Among them, the most important part of the I/O system is the storage. So we need to keep the information and the data in the storage. So we have seen the hierarchy of the storage structure. From the top is a register and so on. Then finally we have the secondary storage. Secondary storage is the for example, hard disk drive was SSD. So we have seen the difference between the solid state and the hard disk drive. Nowadays, the solid state, the couple of years before, people believe the solid state may take over replace all the hard disk drive. But it's not true nowadays. The hard disk drive will still survive and more used because it's cheap and reasonably fast. So if you have such a laptop, many of them still use the hard disk drive instead of the SSD. SSD is relatively expensive, and so mostly nowadays use the smaller devices such as the cell phone or the other, like the USB. So they are based on the DRAM, so which means it's a non-volatile memory. So you can keep the data in the SSD. The hard disk drive is the mechanical operation. Because of that, sometimes it's damaged. But either of them is fine. We can store the data for the persistent disk using what? So we start from the logical memory, logical block addressing. So for the low level formatting, during the low level formatting means it's a kind of the design of the block number. Okay, that is called the logical block addressing, LBA. So the operating system or the application in your computer doesn't have to know about the details of what is the sector number, what is the, just call the logical block number, then this controller will take care to read the data. When you read the data from such a hard disk drive, there is a latency, so you need to consider always such a latency. So to reduce there is two types of latency, rotational latency in the hard disk drive and the seek time latency. Okay, so we consider the seek time latency to calculate how long it takes and the schedule to minimize the seek time latency. That is total the head movement. And in the chapter, I think the 10 or 11 and so on. Then finally, we have designed the software to manage the information which is created by the file. So file is the data structure to keep the information. Actually, it's physically the sequence of the byte, but they are structured by depending on your application, it's differently. So you have the number of files. The problem, the more file you have, it will take a long time to even find the specific file. So we need to have the directory structure. There are different ways of the directory structure: the single level, multi-level, the tree, and eventually graph, and finally a cyclic graph. So we have such a different directory structure. So file structure, directory structure. By combining this, you have file system. So in your project too, you implement the portal file system. That's a simplified file system. Okay. Then eventually you can, if you can understand the hardware level, like the logical block addressing and the hard disk drive, then you can develop your own file system, like the NTFS or the FAT 16 or 32 or the EXT, the file system. There are many different types of the file system in the operating system. Okay. So whether one of you realize, like for example, temporary file system, process file system, and object file system. So however, general purpose file system is the virtual file system. Because we have the number of file system, the virtual file system provide something standard, the I/O standard, and even though you have the different file system, you are able to access the data from the A file system to the B file system. So there are several important concept data structure in your portable file system. You design first the FCB. Okay. So what is a FCB? It's the data structure to make the metadata of your file. Okay, when you search the file, when you delete the file, when you create the file, you don't read the data directly in the file. Instead, you are going to read the FCB. And also, you need to know which block is used and how to allocate. In your implementation, you use contiguous allocation. It's a full chunk of the block. Okay, not only the contiguous but the linked and contiguous, the allocation and index and the linked can be used. Okay. Then you should manage such allocation Plus, you need to manage which block is free. So you can use the B string to manage the free block. And you don't implement the directory structure, but even though you don't implement the directory structure, your implementation should be single level directory structure actually. So you already implemented, but you can make the complicated directory structure by combining this one. Then you have the several operation like the put, get, and such an idea will be nowadays used for the big data distributed file system like the HDFS. Hadoop distributed file system is almost the same as the portable file system that you implement, but it's for each distributed node. Okay, then there is a master node to manage such a distributed file. Okay, then we talk about, we already did in the beginning of semester, but how does the I/O operate? So like the interrupt and so on. So we have seen. So these are the, even though we spend a lot of time, and in terms of number of pages on the textbook, it may be the 800 pages we cover. But that's I don't think it's fully covered all the topic in the graduate level course, because we have the undergraduate student is closely listed. I focus on the kind of in between the graduate level and undergraduate, more close to the graduate level, not fully. So we don't cover the virtual machine security issue and distributed file system, operating system. We didn't cover that. Those are the very important nowadays. And also, it is true, the system, like the operating system or the computer architecture, tends to follow the trend of the application. Nowadays, the hardest application is AI and the deep learning, such as the processing part, so like for example, GPU. The GPU has been used for only the graphics or the quality of the display for gaming and the design, but nowadays it's used for the computation. So operating system should follow such a trend of the computer environment and also cloud computing. So if you are interested in on top of operating system, if you are interested in the more advanced topic for the operating system, we have several opportunities like the Unix programming. So Unix programming is another system level programming. So if you are interested in I got several complaint. Why do I need to use the C++? I never used what is it? Because this is operating system class is focusing on the system programming. So I intentionally asked the provider such the environment. You are very good at such application programming and something the implement Java and object-oriented programming. But still there are a lot of need in the market for the system programming. If you are interested in such a thing, you can take the Unix programming. Then you will be better the system programming. And also, if you are interested in the big data system is based on the main part of the big data system is the distributed system. It's a cluster, which means we need to have the specialized operating system, specifically the file system. Because we have the big data, we cannot keep all the big data in one system. It's distributed. So that is a distributed file system. So if you are interested in such a thing, the big data system, big data course, it will be another chance. Then if you are more interested in the application level and so on, then you can consider the data mining or the machine learning or the deep learning, such as the classes in your future. Okay, so what time? 10:40. So last, the question. Any question? Further regarding to the final exam, same format as the midterm exam. I think I did mostly complete the final exam question, but the 40% is multiple choice, 20 multiple choices question, and the other 60%, I think the 4 or 5 question. So open-ended question is you need to answer or calculate. So be careful. You can bring the calculator, but mostly my question that's not required to use the calculator. You can do the calculating in your mind, but you can use. But cell phone will not be accepted. Okay. So cell phone should be turned off. So you need to bring the analog or the non-memory, non-connected, the calculator. So you can use. So I cannot remember 4 or 5 open-ended questions. So each of them was 10 or 15 points. Okay. So you should be careful. It's better than the computer-based because I can see, but I'm not going to fully consider your partial point. Okay, so you should be careful when you solve the problem. Okay. Any questions?
So which problems we can expect?
No, I do not. Even I cannot remember how many questions I made.
Which sort of problems we can expect from the assignments?
From always my class is based on the textbook. Okay. Then you can do not rely on the PPT file. Do not rely on the homework. Do not. But if you took the class lecture throughout the semester program, you will get the idea how I can focus on which you can focus on. But generally cover most of the topic in the textbook. Okay. Thanks so much, and see you on the Monday.